Because that overall limit exists doesn't mean we cannot say anything about what we're talking about. We can, however, describe our limits from what we called a one-sided limit. So consider the graph. With a jump, or jump discontinuity, as they sometimes say. So let me graph my function. And then I go, the graph of function goes this way, closed circle. Right above it, open circle, goes this way right here. This point right here is 2. The corresponding x value over here is 4. And then up here, this value right here is 7, right? This function right here has a jump in it, correct? Therefore, I can automatically, let me give the function a name. Therefore, I can automatically say this. The limit, LIM, as x approaches the jump for this function right here, does not exist. Let me pause right there and let's see if I have any questions so far.
What does DNE stand for?
DNE stands for does not exist. In other words, there is no limit at that point. All the other examples we've done so far up to this point, we had a limit because the values were squeezing to a specific number. Yes?
Yes.
Okay. So yeah, DNE that stands for does not exist.
So the limit doesn't exist because there's an open circle, or why?
It's because there is a jump in the graph.
Okay.
So let me show it to you in a different way. So remember from our first class right here, when we made the limit and we plotted all these x values right here? Notice how these numbers on both sides right here, come on, be nice to me, are going closer and closer to 7? Yes?
Yeah.
If I was to look at the graph I was just showing to you, they're not getting close to the same number. On this side right here, they're getting close to 4, while on this side right here, they're getting close to 7. Yes? And because that's happening right there, the limit, we say the limit does not exist. All right, and so because that limit does not exist, does not mean that we cannot actually describe this function or say anything about this function right here. And so what we do right here is we first look at the function from 2 sides. Remember when we were doing a limit back in the day, we would have our number line, we'd have the number 2, we have the left right here, we plug numbers in that are getting closer to 2. And then on the side, we have the right side right here. And then we plug numbers that get closer to 2, correct? And that's how we built our table of values. Do you remember that?
Yes.
Okay.
Yes.
So for this graph right here, if I start out on the left side and I pick numbers that are close to 2, so if I pick a number here, and I plug that in, that will take me to, let's switch colors. If I plug this number in right here, and I plug it into the graph, the resulting y value will be right here, correct? Over on the y-axis. If I plug the number that is closer to 2 right here, the corresponding y value will be over here. Yes? If I plug in a number even closer to 2, the corresponding y value will be even closer right here. So looking at these answers that I'm getting right here, can you see that every time I plug in a number that's closer to 2, the corresponding y value I got was closer to 4? Yes?
Yes.
And so because of that, we say right here, the limit for this function, so we say the limit for the function f of x from the left is 4. If I take numbers that are on the left of this function, and these numbers, as they get closer and closer to 2, the function will get closer and closer to 4. Similarly, if I go to the right side of the function, and I choose numbers that are over here on the right, say this point right here, the corresponding y value will be right here. So this is my first one right here. If I choose a number right here, the corresponding value, the second value will be right here. If I choose a number even closer to 2, the number I will get right is right here. And if you look at those 3 dots, you can see each and every time those 3 dots are getting closer and closer to 7.
So,
Go ahead.
So, okay, so there's no limit between if for the whole graph, but for
Exactly.
each separate line, there's a limit.
Exactly. We call those one-sided limits because we only use one side of the function to find the limit. We're either using the left side only or the right side only to find the limit. Okay. It is because we had a breakdown and we know we couldn't get an answer, but we can say, look, there is still a pattern, but it's just only on one side. The limit for, that's a, not a, should be the limit for f of x from the right is 7. Any questions there?
No. Are you gonna do another example like this one?
Yes,
Or okay.
So, of course, we are mathematicians and we don't like writing all of this English, right? Remember, the whole point of this notation right here was to prevent us from writing out all of this English. And so there is a way for us to write this out in a nice compact form. So for the first one, the limit from the left, what we write out, we say is the limit, Lim, as x approaches 2, and then put a minus sign after the 2. See that little minus sign after the 2? That minus sign means I'm taking the limit from the left. It means I'm doing a one-sided limit of the function f of x is 4. So I compress all of that language into this one right here. And then for the second one, down here, I write the limit Lim as x approaches 2 from the right for the function. This is going to be 7. Questions there? Comments? Queries? Concerns? Okay, cool. So let's try again. Let's try another example. We're going to try this one together. So I have my axes, x-axis right here. And I have the graph of a function that looks like this. So the graph of the function that's why my function looks right here. This right here is -3. This right here is -2. And this right here is +4. All right. So my first question to all you guys out there in box world is, does this graph have a jump in it? And if it does, where is that jump?
It does.
It does. And at what value for x is that the jump occur at?
-3.
-3. So this graph has a jump at -3. So a jump. Remember, Mac does make you jump. No, you don't remember that? Crisscross will make you? No. So my first question, A. What is the limit LIM as x approaches -3 for my function f of x? Another way of saying is, what is the overall limit for this function as x approaches -3? Answers. Any answers there for me, please?
Does not exist.
It does not exist. That's right. This limit does not exist. The reason why it doesn't exist is because we're at a jump, correct? Correct? Maybe?
Yeah.
Yes.
So question number B. I want the limit LIM as x approaches -3 from the left of this function right here. What would that limit be?
Is it 0?
No. How do you get 0?
No, it's -2, right?
Yes, it is -2. How do you get -2?
Because that point on the graph is at -3, -2.
So what she said was she took the she went to the point -3. Let's go with a light blue. She went to the point -3 right here, and she said that this is the left side right here of the graph. So from the left side right here, if I approach -3, I can see the point I'm getting close to is this point right here, which has a y value of -2. And so therefore this is going to be -2. Number C. Limit as x approaches -3, this time from the right. See the plus sign right here? That means the right. What is this limit right here? Somebody else who's paying attention.
It isn't -4.
Not -4,
I
but
mean +4.
positive 4. That is right. And so that's going to be our limit right there. Any questions so far on those three limits? Again, all three answers make sense because answers C and B are different. When answers C and B are different, then this answer does not exist. If these two answers were the same, then the D and E would be the same number as well.
Okay, so how are C and B different again?
How I see being different because when I'm finding the answer for C, I'm using this piece of the graph. So I'm going to end up focusing at this point right here. What's the y coordinate at that point? 4. On the other hand, when I'm doing B, I am on the left, so I'm using this graph right here. And so at -3, the y coordinate is -2.
How do
Okay,
you know which side of the graph you're using?
by looking at the sign you see right here.
So the left is positive and the right is negative?
Opposite, the left is negative and the right is positive.
Oh, okay. I see what you're talking about.
Anybody else? Trying to draw this thing properly. All right, so this is our crazy graph right here. So this is -4. This right here is 3. This right here is 7. This right here is 2. This right here is 4. This one right here is 3. This one right here is -3. This one up here is 5. And then the one down here is -4. All right, so I have my graph right here. I'll give you a chance to draw it. I'll just start with one simple question. Go ahead and send me a private message with the answer to the question I'm asking. All right, so that's a yes or no. The first one is a yes or no. So send me a message once you have an answer for me. Send me a private message. Okay, Rodney, hopefully things work out. All right, looks like almost everybody has given me an answer. Waiting for a few more peoples. Okay, a jump is when the graph has a break in it. And so I go to x equals -4. When I go to x equals -4, that takes me to this point right here. And so I look at the graph right here. Does the graph have a jump right here at that point at -4? And the answer is yes, it does. And so the answer to the first question is yes. The graph does have a jump at -4. All right, go ahead and answer these. Just put the number in, or if it doesn't exist, put in D&E in the box for me, please. Oh, by the way, any questions on why the answer is yes?
I just want to clarify
Mhm.
for the customers. Just want to clarify. So since there's a gap between on the y-axis from 2 to 4, that's going to be considered a jump. Is that correct?
That is correct.
All right. And so I'm not sure you had mentioned it because I was trying to pages, but so it's not considered a jump if both of the circles are close and they're connected.
If they're connected, then it is not a jump.
Okay.
Okay. So there's a jump at 3 and there's a jump at 7 as well.
Okay, I'm making a note.
Okay, so limit as x approaches -4 from the left of my function. Number C, limit as x approaches 3 from the right. And then number D, limit as x approaches 7. Okay, I got 3 of them for you. Go ahead and tell me what the answer to each of those limits are. Just put 3 numbers, comma between each one. Or if the limit does not exist, just type in D&E. Let us roll. So the key right here is the observation and reading very carefully. So this question right here, number B, says I am taking a limit as x approaches -4 from the left. Okay, so it's giving you a lot of information right here. So what it means right here is I have to go to this picture. Got to go to this picture right here and got to find -4. That's the first thing right here. I got to find -4. The next thing right here is I have to find the graph that's on the left side. And so see right here, I have highlighted, shaded in the graph that's on the left side right here. And then I go to the coordinate, the point at -4. So if I go to the point at -4, see right here, that's my point at -4. I go across. What y value do I see? 2. And so therefore, the limit, the answer to this problem right here is 2. Questions there? Questions there? Those people who are not sure, I'll put a question mark after the answer. Questions there on this, the first one.
So the little minus sign by the 4 means to the left,
Yes.
not to the right.
Exactly.
Okay.
Okay. Now, the next one.
I have a question.
Yes.
I'm sorry. So, do we need to include left and right in our answers if we?
The answer
Okay.
is just the value.
All right.
Okay. Anybody else? So the next one, again, I'm taking a limit this time as x approaches positive 3, and then it's approaching from the right. And so what that means is I first have to find +3. So you see right here, +3. And then I have to find the piece of the graph that's on the right side. So the piece of the graph right here that's on the right side, that's the piece that I'm highlighting right here. Okay, that's the right of 3. Then to get my answer, I have to go to the dot at 3, that's right here, and then I go across. When I go across, I see I come to the value 3. So this limit right here, the answer for this one right here is 3. Questions there? So the answer to the first one was 2. The answer to the second one is 3. Questions there? Now, the last one, number D. The last one, number D right here, I am taking a limit as x approaches 7. But notice right here, there is no number. When there is no number, we call this a two-side limit, or we have to take the limit from both sides. Okay, when there is no limit, we have to take the limit from both sides. And so what that means for us is, I need to clear this up a little bit. I first have to go to the value 7. So, right, go to the value 7. And I have to consider both sides. I have to consider this side right here. And then I have to consider this side right here. Yes? Can you see that if I was to take this limit on the left side, the answer I would get is 5. And if I were to take this limit on the right side, the answer is -4. Can you see if I take the limit on each of the two sides, I get 2 different answers. Excuse me. Can you guys see that?
Bless you.
Thank you.
Yeah, I can see it.
And the reason is because the graph has a jump at 7.
Yes.
Right?
Yeah.
So if the graph didn't have a jump at 7, what would be the answer?
Well, if it didn't have a jump at, okay, I'll give you an example of one that doesn't have a jump, and so then you'll be able to see right here. And so because of that, the answer right here is does not exist. Okay? Questions? So somebody asked a question.
You
Go ahead.
bring that full circle one more time? Like just like explaining everything one more time.
So the minus right here means what? I am taking the limit from the left, right? When there is no sign right here, it means I'm taking the limit from both sides. For a limit to exist, the two limits from the two sides must be the same number. But in this example, on one side it's 5, the left side is 5, and then on the right side it's -4, and so therefore the limit does not exist.
When we have graphs that deal with jumps, and like for D, if we get a question like D and the graph has jumps, will it always be it doesn't exist?
If we're at a jump, somebody was asking a question, the reverse question. So what happens if I don't have a jump? So let me add one little piece in right here to this graph. So let me add in a -5 right here. So let me add in a -5 right here. And then this point right here, let's call that point right here -1. So I added this point right in right here. So BCDE, if I ask the limit LIM as x approaches -5, sorry. Well, notice there is no plus or minus on that -5, correct? So if I was on the left side of the graph, I can see the graph right here is going to get to the point -1. If on the other side, I'm on the right side of the graph, let's put the right side in green. If I'm on the right side of the graph, again, I will get to the same exact point, and which is again -1. So since both sides are now green, I can now give you a limit for this problem right here. The answer is going to be -1. I could also write the limit as x approaches -5 from the left is -1, and the limit as x approaches -5 from the right of the function is -1. Did that answer your question?
Yes, sort of.
Think,
So for D,
go ahead, I'm listening.
for 7, so it's doesn't exist because one of the sides, what? I'm still confused on that one.
Keep going, because one of the sides was,
Because you don't see it, like it's not on the graph.
oh no, it's
Or-
not because of the open circle. All right, so let me put it this way. If I ask you, what is the limit LIM as x approaches 7 from the left? So that's a minus sign right here. What would that answer be? Anybody? Somebody help her out. Somebody help her out. What would that answer be? If,
You said approaches from the left.
yes, so I'm pushing 7, the value 7 from the left. Yeah, what would that be?
Is it 5?
That would be 5. See, even though there's an open circle right here, the answer is still 5, correct? Remember, the open circle does not play a result in our answer here.
Mhm.
Now, if I ask the same question, but this time from the other side, the limit as x approaches 7, but this time from the right, what would that answer be? That answer would be -4, correct?
Yes.
And so my question, is the limit from the left equal to the limit from the right?
No.
And therefore the limit does not exist. They must be equal to each other. And then the limit exists and is the same number.
Okay, I get it now.
Anybody else? All right, I have 3 more questions to you. I'm going to go this one easy. Going back to college algebra days. Answer me these 3 questions. What is f of 7? That's number f. Yes. What is f of 3? And then what is GH? What is f of -4? Send me the answer to those 3 problems right here. F of 7, f of 3, and f of -4. Again, send me a message. I can give you, shouldn't take you a long time. I give you about a minute to answer. If you don't know, just put the answer in. I don't know. Come on, let's go. Time is against me. I say time is always against you, Professor. That's not your fault.
What are we doing?
F, G, and H, right at the bottom of the screen. I want the answer. Each of those represent an answer. That's college algebra back in the day. Jada, your answers are correct. Jada. Although technically you should not be saying DNA, you said no solution. But let's try. 2 out of 3, Clayton, 2 out of 3. Kamari, no, the answer to that is no, there is but one answer. So, no, the F does not have 2 answers. F only has 1 answer. Mr. Smith. So the answer for G is right. H does not have 2 answers either, Mr. Johnson. That is not right, Rogers. You're thinking about the limit. Remember, this is college algebra. That's before limits existed. Now, people, 60 seconds. If you don't know, just put in there, IDK. Miss Walls. No, Clayton, that's not right. F. Come on. No, come on, that's 2 out of 3. Zia, for the 2, you say you're right. All right, is right. All right, let's see the answers then. So I'm actually going to do them backwards because obviously the F was the hard one. For number H, the thing is you have to go to the closed circle. This is what this college algebra is asking you to do. You just got to go back and find yourself your closed circle. So at -4, the closed circle is right here. And so the answer is 2. At F of 3, the closed circle is right here. And so the answer is 3. Most people got that right. And for number 7, if you look carefully for number 7, there is no closed circle. And because there is no closed circle, this problem has no solution. Some people put in D and E. Technically, that's not correct. D and E is saying that about a limit. You didn't know about D and E back in the day when you didn't college algebra. The correct terminology is that there is no answer, no solution. Okay? Any questions there on F, G, or H?
No, sir.
Okay, then we're going to step forward into time. Move on to the next section. That's a lot of questions, right? Yeah, and y'all definitely have a quiz on this. Definitely going to give me a graph and asking you to find the limits.
How is this being presented to us on a quiz?
I give you the graph and I ask you A, B, C, D, E, F, G.